ZigBee device types are mainly divided into three types, namely coordinators, routers, and terminals. The first is the coordinator. The coordinator is the core component of the ZigBee network and is responsible for creating and initializing new ZigBee networks. It has the highest permissions and is always active. The coordinator's responsibilities include 1. Initiate and manage the network establishment process and assign network addresses to newly added devices. 2. Maintain the security and stability of the network. 3. Provide bridging functions with other wireless standards such as Wi-Fi or Ethernet and other upper-layer networks. Secondly, router nodes play the role of data forwarding in the ZigBee network. They can not only send and receive information, but also serve as intermediate nodes to deliver data packets from other devices. It is mainly responsible for expanding network coverage and routing messages to target nodes or other routers through multi-hop communication. It can assist the coordinator in managing the network, allowing other devices to join or leave the network, and assign addresses. It also records the status of directly connected devices for efficient routing. Finally, end devices are usually leaf nodes in the network, which are mainly used to collect data or control the external environment, such as sensors or actuators. The terminal can only communicate with the parent node, which may be the coordinator or router, cannot communicate directly with other terminal devices, unless there is routing function support in the network, and sleeps most of the time, waking up only when it needs to send or receive data. Storage resources and computing power are relatively weak. Let's talk about the scope and scalability of ZigBee network. Because the physical range of the ZigBee network is limited by the frequency band it uses, the transmission power and the signal attenuation between devices. Under ideal conditions, the single-hop distance can reach tens to hundreds of meters in indoor environments, and further in open areas outdoors. In practical applications, it may be necessary to cover a larger area, so the ZigBee network can expand the coverage area and accommodate more devices by adding router nodes. Each additional router can theoretically further expand the edge of the network and allow more end devices to access it. Realize the functions of joining, routing, and leaving the network of devices. How is the device connected to the network, routed, and disconnected from the network implemented in the ZigBee network? First, the coordinator starts the network establishment process, sets network ID, PANID, channel, network key and other parameters, announces the existence of the network by broadcasting beacon frames, and turns on the permit joining mode for a period of time to allow other devices to join the network. The terminal device will search for beacon frames sent by the coordinator on all channels. After searching for beacon frames from the coordinator, it will send an association request frame to the corresponding coordinator to request to join the network. This request usually contains the identification information of the network you want to join, such as PANID, and the network address the device hopes to obtain. When the coordinator receives the association request frame from the terminal, it performs a series of security verifications, assigns a network unique address to the terminal device after the authentication is successful, and tells the terminal device through the association response frame that the network access authentication is successful. You can communicate with the network the devices in the device are communicating. The ZigBee protocol also allows routing of data packets within the same network to achieve long-distance transmission of data. When transmitting data, the node first checks whether the target device is within direct communication range, reachable by one hop. If so, the data is sent directly, otherwise, its local routing table is queried to find the best path to the target device. When the routing node receives the RREP information, the routing node forwards the data to the next hop device. This process will be repeated for each device hop until the data reaches the destination device. When a device decides to leave the network, it will send a command to leave the network to its parent node, usually a router or coordinator. After the parent node receives and processes the off-network request, it sends a confirmation message to the device to confirm that it is about to leave the network. After confirming that the device is offline, the parent node will release the device's address in the network, update its routing table, and delete routing information related to the device. If the off-net device is a router, its connected child nodes need to be readdressed and a new parent node selected. After completing the above steps, the device officially leaves the network, stops communicating with other devices on the network, and may enter sleep mode to save power. After the off-grid action is completed, the network management layer, such as the network server, will learn that the device is off-grid, update the network status information it maintains accordingly, and notify the upper layer application that the device has been off-grid.